Hello, fabulous friends. So today we're going to talk about pages 604 and 605 in our science workbook. Okay, so let's go ahead and jump right on into it. So, adding it up, I'm on page 604, so I need you to stay with me. If I ask you to underline something with your pencil, I need you to underline it. If I ask you to highlight, you need to highlight with me. Okay, let's go ahead and start. So, what happens to the mass of substances during physical or chemical changes? Okay, so with your pencil, underline active reading. As you read these pages, underline examples of conservation of mass. Okay, you can put your pencil down. I'm going to start reading the paragraph, so I need you to follow along and stay with me. During physical and chemical changes, matter may change its appearance or its identity. In either type of change, in orange highlighter, the total mass of the matter before and after the change remains the same. This is called conservation of mass. You can put down your orange highlighter now. To conserve means to save. Okay, for example, as water boils, it seems to disappear. However, the total mass of the particles of water vapor in the air equals the mass of the water that boiled away. Suppose you tear a 100-gram cardboard box into pieces. The total mass of all the pieces will also be 100 grams. The mass of the cardboard box stays the same. In this example, however, the volume of the cardboard box changes because tearing it into pieces causes it to lose its shape. Okay, now let's talk about the photos over here on the side of the page. Now we have this salad, and we have the different things that go into the salad. So we have the cucumbers that are 75 grams, we have the lettuce that is 110 grams, and then we have the carrots that are 90 grams. Okay, so in white text, it says the total mass of the mixed salad is the sum of the masses of the vegetables in it. Now, what does sum mean? S-U-M. I'll give you a second. Yeah. If you said addition, you're exactly correct. So in order to add, what do I need to add? Yeah, I need to add the cucumbers, the lettuce, and the carrots. But what am I adding of those things? You're exactly right. I'm adding the 75 grams, the 110 grams, and 90 grams together. Now, whenever you put your answer in this little white box right here, you need to make sure that you have your label, which is what? Grams. Yes, okay. So let's go back to that active reading. It says to underline examples of conservation of mass. Now, let's think. Where would an example of conservation of mass be? I'll give you a second to think. Okay, so I'm going to be underlining our active reading in green, so follow along with me. So if you said it starts at suppose you tear 100-gram cardboard box into pieces, you're exactly right. But I'm going to be underlining everything in the text all the way to, I'm getting there, because tearing it into pieces causes it to lose its shape. Yeah. There's a lot to underline, so I'll give you a second to finish that. Okay, the next thing that I need to underline on this page that gives me an example of conservation of mass. What would it be? Give you a second. Yeah, you're exactly right. The description of how to find the mass of the salad. So I'm going to underline the total mass of the mixed salad is the sum of the masses of the vegetables in it. Good job. Okay. So really quick, let's discuss where it says the water boils seem to disappear in this text. So let's just go back to that for a quick little second. So it says, I'm just going to mark my paper up in purple. You don't have to mark it up. Okay, so it says, as water boils, it seems to disappear. Okay, so the total mass of the particles of water vapor in the air equals the mass of the water that boiled away. So mass and volume, they describe the same property, but it's important to remember that the volume of the water increases because as it's changing to a gas, the particles of that water are spreading out. Does that make sense? Okay, let's move on. Okie dokie. So now I'm on page 605, so I need you to stay with me just a little bit longer. Just hang in there tight. Okay, I'm going to start reading the paragraph, so I need you to stay with me. A chemical change turns one kind of matter into another. However, in pink highlighter, the mass of the matter stays the same. You can put the pink highlighter down. It can be tricky to compare, though. Something to keep in mind. It can be tricky to compare, though. Okay, in your pink highlighter, first, you must collect and measure the mass of everything you begin with. Then, you must collect and measure the mass of everything you are left with. Okay, you can put that cap on your pink highlighter and put it down. When wood burns, it combines with oxygen from the air. Burning produces ashes, smoke, and other gases. The mass of the wood and oxygen equals the mass of the ashes, smoke, and gases that are produced. Okay, let's think back to our active reading. It said to underline examples of conservation of mass. Is there anything in here that I just read that would be an example of conservation of mass? I'll give you a second. Okay, so I'm going to underline in green again so that you can see where I'm underlining the active reading. If you said this paragraph that starts when wood burns, I'm going to underline this entire paragraph. You're exactly right. This whole paragraph is an example of conservation of mass. Because conservation, so the word conserve, which is the root word of conservation, conserve comes from an old Latin term, okay, which means to keep or preserve. So the total amount of matter is kept or preserved as it goes through chemical or physical changes. Okay, now with that knowledge, let's go over and look at our example pictures that it has. Okay, so if we look, we have picture 1, we have picture 2, and we have picture 3. Okay, so I'm going to read this little description down here, and I need you to stay with me. During this chemical reaction, the flask is sealed. Nothing can enter or leave, so the final mass equals the starting mass. Okay, so I'm going to erase my circles that I made on my paper so that you can see. Okie dokie. So, the flask is sealed. What is sealing the flask? Do you know? If you said this little cork right here, you're exactly right. And you can see it. So that's what's sealing the flask. Now, is there something inside of the flask that you can see? I'll give you a second. Yeah. Can you see the little test tube? It has something yellow in it. So the starting value, the starting mass of this flask is right here, that 300.23 grams. Now, the final mass is also 300.23 grams. So nothing could leave or enter into that flask as you were trying to find the mass. Okay, so let's think back to our active reading really quick. The underlining examples of conservation of mass. Is there one more? I'll let you take a second to think. Yeah, there is. And where is it? If you said during this chemical reaction, the flask is sealed, nothing can enter or leave, so the final mass equals the starting mass, you would be correct. Okay. Now, as you can see, do the math. I have a blue X over do the math. So I want you to do the same. I want you to take your blue highlighter and mark an X on do the math. It is your lucky day. You don't have to do that. What? Okay, let's move on. Okay, so make sure to turn in a photo of each page on Google Classroom before you click that turn in button. Okay, thank you so much for watching my video. I love you guys and I miss you so much.